Right, the quotient rule. This is very much like the product rule. The only difference here is instead of being the product of two things, it's the quotient, i.e. the fraction of two functions. So again, u and v are both functions of x. This formula is more complicated, but because of that, you get given it in the exam. So this is in the formula book, so you don't have to remember it. Notice here, because it's not two things times together, it matters which way you pick them. So u is definitely the thing on top. And so what you get is a very similar thing up here. It's v left alone times by the derivative of u minus u left alone, the top thing, times by the derivative of the bottom. Is a minus here rather than the plus, like it was in the product rule. And then on the bottom, we've got v squared. So it's just the thing that was on the bottom squared. Essentially, with the quotient rule, you're picking the things the right way around and then just popping them into the formula. So if we have a go at it, here is something which is a quotient. We're going to pick u and v. So u is the thing on top, sine x. V is the thing on the bottom, which would be 2x plus 1. Differentiating both of them, du dx is cos x, and then dv dx is 2. Okay, we need to put that together in the right order. So let's write out dy dx, and that equals, if we look back at this thing, v du dx, so it would be that one times that one, the order matters here. I'm going to put it in brackets, so 2x plus 1, the whole of that thing, times by this, cos x, minus the other way around, so minus that times that, which would be 2 sine x, all over. And then on the bottom, it's literally whatever v was squared. So v was this thing here. So if I pop it in a bracket, 2x plus 1, all squared. Right, let's do another example. Okay, so here's another one we're going to have a go at. It's a bit more complicated now. So again, I'm going to pick them. So u would equal the top thing, 4x minus 3 all cubed. V is going to equal the bottom, 2x. Differentiating them both, du dx, well that thing up there is a bracket. We could use the chain rule, so we times down by the 3, we times by the derivative of what was inside, so 3 times 4 would be 12, and then we'd still have the same bracket, 4x minus 3, close brackets, and take 1 away from the power. So it'd be power of 2, so a bit messy. And then dv dx would just be 2. Just differentiating that one. If you want to justify this, you could use the chain rule. You could do a substitution. We've already used u, which is a bit awkward, but pick any letter. P equals the thing in the middle, and you can use the chain rule. But by observation is a lot quicker. Putting it all together, dy dx is, well, we've got v du dx, so it'd be that thing times this thing. Well, 2 times 12 is 24. X to the power, so 4x minus 3, all squared, minus u dv dx, so that thing times that thing, 2 4x minus 3 all cubed, over, and then we want v squared, which is this thing squared, which would be 4x squared. I'm squaring both the 2 and the x. I'm not going to bother simplifying that. It does simplify, but it's going to be awkward. Let's just leave it like that. Right, I'm going to give you one to have a go at. So, y equals e to the 3x over, let's use cos x. Right, pause the video, have a go. Okay, so there's u, is the thing on the top, there's v, is the thing on the bottom. Differentiating e to the 3x, well the 3 comes down. Again, it's use of the chain rule, so it's 3e to the 3x. We don't take 1 away from the power. Cos x goes to minus sine x, careful with the negative there. And so putting it all together, dy dx equals v du dx, so 3 cos x e to the 3x, or whatever order you want to write that in, minus, that thing times that thing, was minus from the quotient rule, but we've got another minus around. So minus and a minus makes a plus, and we've got a sine x e to the 3x. If you wanted, there's some nice factorisation you can do on the top. On the bottom, we want v squared, so be cos squared of x. So again, you can do some simplification, but I'm going to leave it like that.